All right, guys, here we go. So this is our next lesson on trig. There's going to be multiple parts of this video. You can, of course, fast forward to the different parts you want. I'm going to do some examples from last time. I'm going to talk about how do you find the angle again. I know that was in my last video, but I'm going to repeat it in this video. And then finally, I'm going to talk about angles of elevation and depression. So if you just need the new stuff, fast forward all the way to angles of elevation and depression. But I'm going to work through some examples here just in case anyone needs to see them. So on every single one of these problems, first thing we do is we type or we write down so, ka, toa. Those have all of our formulas, right? For instance, sine is sin for s, opposite, and hypotenuse. That is my sine formula. It means that the sine of an angle equals opposite over hypotenuse. Same idea on the other two. So if you know this word, so, ka, toa, toa, then you have your three trig ratios built into the word. All right, so keeping that in mind, here's how we do the problems. We identify the angle we're going to work on. How many choices do we have? We have two choices. We could work on the 13 or we could work on this corner, the 77. You can pick either one, but don't choose the 90. We don't do trig with the 90-degree angle. So you can either do the 13 or the 77, but I would do the one they gave you. So in this case, we have 13 degrees. We know that we know that x is opposite the 13 and 4 is adjacent. Remember, adjacent means next to or touching. And this side that we don't have anything on is the hypotenuse, but I'm not worried about that. So we're talking about OA. So we go up here. Which formula is OA? That is tangent. So we know for this problem that the tangent of theta equals opposite over adjacent. That is the tangent of 13 equals opposite over adjacent. So x equals 4 times the tangent of 13. Just as a reminder, you would doing times 4 to cancel out the 4s. If x is up high, all you got to do is multiply. Get it right your first try. So that's what x equals. We type that in, 4 times the tangent of 13, and I get 0.923. And that is how big x is. Next problem. We have 24 degrees. 7 is opposite my 24. Y is the hypotenuse. And that's the so part. And so, before you go. So we know it's sine of theta equals opposite over hypotenuse. So we plug in our numbers. The sine of 24 is going to equal 7 over y. Now, how do we solve this? I'll show you the long way, but remember they just switched positions. It's like you're multiplying y to both sides. Those cancel out. So you have y sine 24 equals 7, and then you divide both sides by sine 24. I am not going to do this probably ever again because they end up just switching positions, right? The y and the sine 24 just end up in switching positions. But it's 7 divided by sine 24. Type that in my calculator, and I get 17.210. We're rounding to the nearest thousands unless we're told otherwise. What if we left this 0 off? Let's say we didn't write the 0. What would you think? You would think I rounded to the nearest hundredth. So if we're supposed to round to the nearest thousands, then yes, we do need the 0 there. All right, 70 degrees. This is the adjacent leg. This is the hypotenuse. That's the ka part of SOHCAHTOA. So that means the cosine of theta equals adjacent over hypotenuse. That means the cosine of 70 equals 14 over w. And again, what happens here? They just switch places. If w is down low, they switch places, you know. You got to get triggy with it. So they just switch positions. You can do all the work if you want every time, but they just switch positions. So it's 14 over the cosine of 70. And I get 40.933. Over here, I don't have to do sine, cosine, tangent. This is just regular Pythagorean theorem. If you know two sides, regular Pythagorean theorem. Write your triples down. Right now, pause the video and write them down. Can you remember your 3 triples? I hope you're trying before you watch this. Those are your four triples. I meant to say four. Those are your four main triples. You need to know these. So in this problem, divide by 2, 7. Divide by 2, 25. So this is a 7, 24, 25. So multiply the 2 back in, and it'd have to be 48. Don't forget your triples. All right, something new. Well, it's not really new if you watched my last video, but if you're in my class this year, it is something new. X is the angle. So you do not have to watch the next 2 minutes or so. The next 2 minutes is going to be Algebra 2. But it does help you understand the process a little bit. But I'm gonna talk about some Algebra 2. So if I said 10x equals 20, how do you solve for x? You would divide by 10, right? Because the inverse of multiplication is division. If I said x minus 10 equals 20, what would you do? You would add 10 because adding is the inverse of subtracting. Those are called inverse operations. We're going to talk about something called inverse functions. So again, this is Algebra 2. You don't have to know this. You can fast forward back to the trig if you want, but you'll have a function like f of x equals 3x plus 10. And you'll have to figure out the inverse function. Inverse is undo, right? How do you undo times 10? You divide by 10. How do you undo minus 10? You add 10. So how do you undo an entire function? Well, what if I said 3x plus 10 equals 0? How would you solve that? You would subtract 10 and divide by 3, right? That's how you would undo all that stuff. So it's called an inverse function, and we write it like this. That -1 in this context means inverse. And it's kind of like the word can. Like I can do trigonometry, or I hit you with a can in the face, or a can of beans. I don't know. The word can has different meanings. Well, if you see 10 to the -1, this means the reciprocal of 10 to the first. This is an exponent. That is an exponent in that context. But here, in this context, it means the inverse of f of x. So just so you know. All right. So how do you undo 3x plus 10? Well, you would have to first subtract the 10 and then divide off the 3. These are inverse functions. What does that mean? Okay, let's say that I have the number 4. If I do f of 4, that would be 3 times 4 plus 10, which is 22. So if I pick any number, and I run it through this function, it's going to do it times 3 and then add 10. But what if I want my 4 back? How do I take this output and get my 4 back? Well, if I plug in that answer, if I plug in the answer here, 22 minus 10 divided by 3, what is 22 minus 10? That'd be 12 divided by 3. I got my 4 back. This function undid everything this function did. It's called an inverse function. So if you want to undo a function, it's more than just a division or a multiplication. It's a series of things to undo everything you just did. So what does that have to do with trigonometry? Let's take a look. So if I'm solving this question, this is opposite hypotenuse, right? We're talking about from the x. This is opposite the x, and that's the hypotenuse. So that's the so before you go. It's the sine equals opposite over hypotenuse, part of SOHCAHTOA. So the sine of the angle, well, the angle is x equals opposite 12 over hypotenuse 18. And I showed you guys this in the last video. So if you watched my videos, you've already been taught this. Here's the thing. Sine is not a number. This is not sine times x. I cannot just divide by sine. No, that's not how it works. Sine's not a number. Sine is a function. I don't even know what that function is. I don't know how they do it. In my calculator, when I type in sine 22 and it says 0.3746, where are they getting 0.3746? I don't know. But they take the 22 and they run it through some formula, something like this, and they get an answer. And it's some decimal, right? Okay, well, how do we undo a formula? How? Say it louder. Inverse. The inverse of sine will undo sine. They will cancel each other out, leaving you with just the x. right? Think about this. If I plugged x into this, it gives me an answer, and then I take that answer and plug it into the inverse, I go right back to where I started, right? If I take a number and plug it into a function, and then take that answer and plug it into the inverse, I get the number I started with, right? So I get just x. But if I take the inverse of one side, I have to take the inverse of both sides. That's what algebra tells us, to keep both sides equal. This is the inverse sine of 12 over 18. So that angle is 41.810 degrees. It's going to be probably 10 minutes. Let's go do some more example problems. So I talked about a whole bunch of stuff there. At the end of the day, how do we actually solve the problems? All right, here we go. Got an angle. It's x. 5 is opposite. 4 is adjacent. That's the TOA part of SOHCAHTOA. So we know that the tangent of x equals 5 over 4, opposite over adjacent. Now, critical thinking, 1 second. Almost all the most common mistakes can be caught if you just ask yourself, is it logical? Is x, think real hard, greater than, less than, or equal to 45 degrees? You can tell. X is across from the 5. The other side is 4. If this was 5 and 5, it would be exactly 45 degrees. That's an isosceles triangle. But since 5 is bigger than 4, I know x is bigger than 45 degrees. And just knowing that can help me catch some of the biggest problems people have. So let's go back to this, though. How do we undo tangent? We do inverse tangent of both sides. I don't expect you to show all that work every time, but inverse tangent cancels out tangent, and then you got to take the inverse tangent of the other side as well. Then this is all in the calculator now. Inverse tangent of 5 over 4, I better get a number bigger than 45, and I do. I get 51.340. So I know that angle's 51.340. Next one, going quickly, this would be adjacent hypotenuse. So what part of it? SOHCAHTOA, it's the SOHCAHTOA. So we have the cosine of the angle equals adjacent over hypotenuse. Again, how do we undo cosine? We're going to do inverse cosine of adjacent over hypotenuse. And you can actually just reduce that and say 6 over 7. You'll get the same answer. Remember that similar triangles have the exact same angles. So if you type in 6 over 7, you'll get the same answer as if you type in 60 over 70. And I get 31.003 degrees. Crushing it. All right, mixed practice. I'm not going to do these on the video. It's the same work we've been doing. Go watch those examples again. But we got to talk about angles of elevation and depression. And it might be kind of hard on this because it's kind of hard to have these examples. But elevate is to like rise or go above. To depress is to go down. That's what those words mean, right? Elevation and depression, up and down. If you have like a mattress, like if you have what are those foam? What's the foam called? I don't know. If you have a foam mattress and you've used it for a long time, Tempur-Pedic mattress, eventually they're going to have little dips in them. They're going to be depressed in areas as you use them over time. That is depression. Depression is down. Elevation is up. Angles of elevation and depression are very, very specific. An angle of elevation has to involve a horizontal line. So let me give you an example. Let's say I'm standing right here. This is me. Boop, boop, boop. And as you guys know, my arms are huge. So I got my big arms in there. And in my room, on the ceiling, I got this little fire thing that's like this little alarm. I don't know. But if I want to look at the little alarm, right, I have to look above my horizontal line of sight. So imagine a horizontal line coming straight out of my eyeballs. What do I have to do to look at that thing on the ceiling? I have to raise either my eyeballs or my head until I can see the object. So the angle above a horizontal line is called an angle of elevation. Got to have a horizontal line. All right. What if I want to look at one of my students? So I got Joe Bob down here, and he's sitting at his desk, and he's just a great student. And he's sitting there, and I want to look at Joe Bob. What do I have to do? I have to turn either my head or my eyes down. So what is that? So to look at Joe Bob, I have depression. So when I look at the thing on the ceiling, elevation. When I look at my students, depression. That's a joke, by the way. That's a joke. Don't get your feelings hurt, hopefully. I'm just kidding. I love looking at my students. But just in general, if I'm looking down at anything, there is an angle of depression involved. Depression is the angle below a horizontal line. So let me show you some examples within triangles. If I draw this triangle, ask yourself, is there an angle of elevation, an angle of depression, neither one, or both? Well, the answer is never both. So if you're thinking both, is this an angle of depression, elevation, or neither? What do you think? Think real hard. Think about what I said. It is neither. Is there a horizontal line involved? No. No horizontal, no depression. No horizontal, no elevation. Down does not mean depressed. This is an angle facing down. Down is not depressed. Depressed is always down, but down is not always depressed. Rectangles are not always squares, but squares are always rectangles. So just because it's facing down, Mr. Man, it's facing down. I know, it's facing down. Doesn't mean it's depressed. You can be down without being depressed. This one is elevation. Why? Because there's a horizontal line involved. So that triangle had an elevation. I call that an elevation right triangle. And then I have a depression triangle over here. Oop, I gave it away. But this triangle has a depression. This has an angle below a horizontal line. How about this one? Is this one elevation? It's facing up. No. It's facing up. I know it's facing up. But up is not elevation. You've got to have a horizontal line. So this one has elevation. This one has depression. Let's go look at some of the triangles we had before. How about this one? Elevation, depression, both, or neither? What do you think? The answer is neither. There's not a single horizontal line in the picture. No, none of them. How about this guy? Look real hard. Think real hard. This one has two depressions. Two angles below the horizontal line. And this one, this is what we just drew. That's an angle of elevation. And this is not depression. Down is not depressed. No, that doesn't have a horizontal line. All right. Another quick note. Let's say Joe Bob down here, look at his horizontal line. When he looks up, he has elevation. I want you to look real hard at this. What do you think is true about my depression and his elevation? What if I had to look down 6 degrees to see him? This would also be 6 degrees. Look, those are horizontal lines. Horizontal lines make alternate interior angles, and they are parallel. So one elevation is always the other one's depression. Same thing looking up here. This fire thingy on my ceiling, its depression is the same as my elevation. So if my elevation is 10 degrees to look up, its depression is 10 degrees to look down. So between the same two objects, the elevation and depression are going to be the same number. One person's elevation is the exact same number as another person's depression, and vice versa. So we're going to do these word problems real quick. From a point on the ground 11 feet from the base of a flagpole, the angle of elevation to the top of the pole is 44 degrees. How tall is the flagpole? Well, it mentions angle of elevation. I'm drawing an elevation triangle. 11 feet from the base of a flagpole, is that going to be vertical, horizontal, or the diagonal? Well, from the base of the flagpole is going to be the horizontal. And a 44-degree angle of elevation, we know this has to go here. How tall is the flagpole? That's going to be my vertical number. Once it's set up like this, now it's just trig. And I'm going to do the trig really fast, but this would be tangent equals opposite over adjacent. If x is up high, all you got to do is multiply. Get it right your first try. So x equals 11 times the tangent of 44. I'm not even going to type it in, but that's what it is. You type it in, you get the decimal. Next problem, we're going to go quick. A plane takes off 300 yards in front of an 80-foot tall building. At what angle of elevation must the plane take off in order to avoid crashing into the building? Assume the plane flies in a straight line that is constant. Well, they mentioned angle of elevation. That's a really good hint, I guess. It's a good chance it's going to be an elevation triangle. Now, this one's going to cause us issues. Hopefully you caught it. Yards and feet. We know that 3 feet equals 1 yard. So I'm going to make them all feet. So this is going to be 900 feet. So I don't care about units until they're different units. I got to make sure they're the same units. I know science teachers would hit me in the face for saying that, but I just can't care about units until I realize they're different. We got to make sure that the units match. So for 900 feet in front of the building, that'd be a horizontal distance. The building is 80 feet tall. What is the angle of elevation? So this is our triangle. So this is opposite, this is adjacent, so this would be the tangent of x equals opposite over adjacent, and my angle is going to be way less than 45. 80 is way less than 900, but it's going to be the inverse tangent of 80 over 900, and I'm not going to type that in. I know it's going to be real small, but that would be the situation here. Okay, we got two more, so keep watching if you want to see them. The last one's probably the hardest one. The last one's a challenge question. Maybe stick around for that. But it says, from the window of a building, Vishnu spots his family dog sitting near a bench. People got really frustrated. I'm going to change it to on a bench. You happy? Okay, he's on the bench. If Vishnu knows the bench is 100 feet from his building and that he is 121 feet high, what is the angle of depression? So I would draw a depression triangle. I have an angle of depression here, 121 feet high, 100 feet from the building, angle of depression. Those are the parts. So this would be the tangent of the angle equals opposite over adjacent. So we have to take the inverse tangent. And again, I'm not going to type it in, but that's the answer. This would be a good chance maybe just to talk to you real quick. Could I draw the same situation using elevation? Remember that elevation for the one person is depression for the other, and they're alternate interior angles. So while it's not in this triangle, you could extend a horizontal line here. That would also be x. Or you could draw this triangle. Elevation and depression are going to match. They're going to be the same numbers. So I talked about this a little bit a second ago, but some people like to always draw elevation triangles. You can do that. Just know that the depression and the elevation are the same number because of alternate interior angles. And this would be the same work that we just did. So you're allowed to do that. All right, one more question. Sarvesh is standing 35 feet from a statue of Dirk Nowitzki. His angle of elevation to the top is that. His angle of depression to the bottom is that. So this is kind of weird, but if I'm standing here, let's say I have a wall. My horizontal line hits somewhere on the wall. I have elevation to the top of the wall. I have depression to the bottom of the wall. Combine that entire distance, I have the entire height of the wall. But it takes two triangles to do it. Elevation to the top, depression to the bottom. Two triangles to get there. So that's kind of the situation. I'm not going to draw Dirk Nowitzki, but in this situation, we are 35 feet from a statue. It could be a wall, statue, whatever. My elevation is 27.2 to the top. My depression is 9.7 to the bottom. So I'm going to call this x and y, and I have to solve them individually. So for x, that would be the tangent of 27.2 equals x over 35. So I'm going to multiply. If x is up high, all you got to do is multiply. So it'll be x equals 35 times the tangent of 27.2. And that's it. I'm going to stop right there. Don't type that in and round that. We don't round until the very end. Leave it exact. It's even easier because now I don't even have to type anything in. Just leave it alone. And then for the other triangle, 9.7, opposite. So this would be, again, tangent of 9.7 equals opposite over adjacent. If y is up high, all you got to do is multiply. So it'd be 35 times the tangent of 9.7. And then we have the bottom piece. So how do we get the overall height of the statue? We're going to add those two numbers together. I'm going to go ahead and type this one in. Guys, you don't round to the very end. You leave them exact. Only at the end do we round. So I'm literally typing in 35 times the tangent of 27.2 plus 35 times the tangent of 9.7. And I get 23.970. Tough question there. We're going to keep having tough questions. Hopefully some of this helped. Have fun getting tricky with it.